Hello, yo, welcome back. All right. So now we are going to be looking at revision question on progression. Okay, that is sequence and series. All right. So let's start with the very first question. Now the question goes this way: the first term of a geometric progression is twice its common ratio. Find the sum of the first two terms of the GP if its sum to infinity is 8. All right. So now, even though the question is a word problem and it's looking complicated, right? The only way to actually tackle this is to write the statement of the word problem. Okay. So what we do is let's start with the very first statement. The first term of a geometric progression is twice its common ratio. So we'll write that down. The symbol for first term is actually A. Is twice the common ratio, that is 2 times R. Okay, so that is the very first statement. So we are being asked to find the sum of the two terms of the GP if the sum to infinity. All right, so we are being told that the sum to infinity, all right, the sum to infinity is 8. And you know very well that this formula for the sum to infinity of a GP is given as A all over, all right? 1 minus r or r minus 1, depending as the case may be, um, depend on the value of the r. If r is greater than 1, all right, uh, if r is greater than 1, we use r minus 1. If r is less than 1, we use 1 minus r. So can we actually predict, okay, what r is going to be? Yes, we can, because since we are told that the first term is 2 times the common ratio. All right. So that means the common ratio is the first term all over 2. So from what we have now, all right, from all indication, okay, the R, okay, if I should actually express R here, R is equal to the first term all over 2. Okay. So R is actually less than the common ratio is actually less than 1. Yes. Okay. The common ratio is going to be less than 1. But whatever the case may be, let's actually uh, look at that. Let's look at it. Let's use this formula: A all over 1 minus R. All right. So since we are told that the sum to infinity according to the question is 8, that is going to be 8 equal to A. All right. So we don't know what our A is. All right. But we are told that A here is 2R. Okay. So there's going to be 2R all over 1 minus R. So I have to cross multiply. Cross multiplying 2R multiplied by 1 will give me 2R. Of course, 8 multiplied by 1 is going to give me 8. 8 multiplied by R is going to give me minus 8R. Okay, collecting like terms. 2R, all right, if I take minus 8R to the other side, that's going to be 2R plus 8R. So that's going to be 10R. 10R is equal to 8. That way I can find the value of R, all right? Okay, so with what I have now, I can find the value of R. So, of course, I got to shift this a bit. Okay, so with what I have, please pardon me. Okay, so with what I have here, I'll now have that R is equal to 8 all over 10. If I break it down, 2 going to 8, that's going to be 4. Going to 10, that is going to be 5. So that is my R, okay? So that is the unknown. That's what I'm looking for. But the question now is, that's not really what I'm looking for. I need to find the R because I'm being asked to find the sum of the first two terms. Okay, so sum of the first two terms. Know that the sum of the nth term of a GP is given by the formula A, all right, bracket open 1 minus R raised per n divided by 1 minus R, okay? So why am I using this formula? I'm using this formula because already for the sum to infinity, I use 1 minus R, okay? So it is going to be very much ideal if I also use 1 minus R for the sum of the first two terms. So I'm looking for the sum of the first two terms, that is going to be x2. So it's equal to the first term. The first term is 2 times the common ratio. All right? So what is our common ratio? Our common ratio is 4 over 2. So 2 times 4 over 2, that's going to be 2 times 4 over 2 times 4 is 8. That's 8 all over 5. Okay? Or better still, let me write that down. All right, so, okay, let's look at, that's 8 all over 5 because we know that the first time A is equal to 2R, and that's going to be 2 times 4 all over 5, which is 8 all over 5. So putting that value here, so that's going to be 8 all over 5, bracket open, 1 minus the common ratio, which of course is 4 all over 5, all raised to the power of n. N is a 2. All right. Then divided by 1 minus 4 all over 5. So let's finalize this. This is x2 now is going to be equal to x all over 5, bracket open. This is going to be 1. 4 square is, of course, is 16. 5 square is 25. Okay. All right. Here we go. If we simplify this particular fraction at the denominator, what we end up having is 5 minus 4 all over 5. All right, so let's finalize everything, okay? So I will have to divide this. So this is going to be 8 x2 now. This is going to be equal to 8 all over 5. If you work on the fraction, okay? If you work on that fraction inside the bracket, it's going to be 25 minus 16 all over 25. Okay. Equal to 5 minus 1. Of course, that's 1 all over 5. So this is going to be equal to 25 minus 16, all right? 25 minus 16 is okay? That should be 9 if I'm not mistaken. Okay, so let's do that. 25 minus 16. Please pardon me. 25 minus 16. All right, that's 9. So here I'm having 8 all over 5, then times 9 all over 25. Then, of course, divided by, I'll change it to multiplication sign. Okay, so 5 all over 1. 5 cancels 5. All right, so I'm only left with 8 times 9 divided by 5 times 25. Okay, so 8 times 9 is 72. So that's going to be 72 all over 125. All right, so that is the sum of the first two terms. Though it's long, we can still go through it again. All right, so here we go. Let's look at this question right here. Okay, and the question goes this way. The third term of an AP is 4x minus 2y. The ninth term is 10x minus 8y. Find the common difference. So, of course, you know what you do. We write the statement. Okay, so the third term is T3. All right, and of course, T3, the nth term of a GP is always a raised power of n minus 1. So the third term is going to be a raised to power, please pardon me, the nth term of an AP, please pardon me, the nth term of an AP is always AR raised to power n minus 1. So the third term is going to be AR raised to power 3 minus 1, which of course is 2. Okay, so we are told that that is 4x minus 2y. We are also told that the ninth term, T9, which of course is AR raised power 9 minus 1, that is 8, is 10. Oh, please pardon me. This is supposed to be AP, not GP. I'm using the formula of GP. For AP, okay, the nth term of an AP is A plus n minus 1 multiplied by D. A plus n minus 1. Okay, so for T3, that's going to be A plus 2 minus 1. That is multiplied by D. All right, that's going to be A plus 1D, A plus D. Okay, so which of course is 4x minus 2y. For the ninth term, okay, so that's going to be A plus 9 minus 1 multiplied by D. 9 minus 1 is 8. 8D, okay, so which is 10x minus 8y. So these are two equations, equation 1, and this is equation 2. So we are looking for the common difference. It's just very easy, okay? So what I will just do is to subtract equation 2 from equation 1. So I will just subtract. A minus A is equal to 0. A is gone, okay? So what I'm going to have is D minus 8D. D minus 8D will give me minus 7D. Of course, 4x minus 10x, that's going to give me minus 6x. Minus 2y minus into minus 8y. Okay, minus into minus is plus. That's going to be minus 2y plus 8y. Okay, so minus 2y plus 8y will give me plus 6y. Okay, so invariably now, with what we have, so I can actually make D the subject. So D now is going to be equal to minus 6x plus 6y. Okay, then divided by minus 7. Okay. Oh, the third term of the AP is supposed to be A plus 2D. Please just pardon me, it's like my mind is not really, it's wandering somewhere. Okay, T3 is A plus 2D. That's going to be 3 minus 1, which is 2D. So no wonder it's actually, everything is looking so complicated. All right, so that is just what you need to correct, A plus 2D. So when we are subtracting now, what we are supposed to have at this point is not supposed to be 7D. It's supposed to be 2 minus 8D, that is 6D. All right, so invariably now, okay, so I have to just correct that. This is supposed to be minus 6. Please pardon me. All right, pardon me. Okay, so this is going to be D is going to be equal to minus 6x all over minus 6 plus 6y all over minus 6, right? Minus minus, all right? That's plus 6 all over 6, that is x. Then, of course, plus minus is minus. 6 all over 6 is y, okay? So the common difference is x minus y. Please correct that, correct it, okay? All right, and here I have another question. This one goes this way. The fifth term of an AP is 24. So we still write that down. The fifth term. So this time around, hopefully I will not make that mistake again. So T5, you know exactly what it's going to be. That's going to be A plus 4D. All right, and we are told that it's 24. And we also told that the 11th term, T11, okay, you know what that's going to be? That's going to be A plus 10D. It's 96. Equation 1, equation 2. Okay, so we are asked to find the first term. Okay, so for us to be able to find the first term, okay, so let's find the common difference. So we'll actually eliminate, simple, let's eliminate by subtracting equation 2 from equation 1. Well, A minus A will give me 0, so A is eliminated. Of course, 4D minus 10D, that's going to give me minus 60. Okay, so 24 minus 96, that is minus 72. Of course, minus cancels minus, so D is going to be equal to our 72. Okay, so this is going to be equal to 72 divided by 6, right? So 72 all over divided by 6. All that I have, that's 12. So since I've gotten my D now, it is very much easier to find the A from any of this equation. So from equation 1, okay, so if I want to find my A from equation 1, you know very well that A is going to be equal to, okay, so 24 minus 4D, all right, from equation 1. So that's going to be equal to, my A now is going to be equal to 24 minus 4 times the D, which of course is 12. So A is going to be equal to 24 minus 4 times 12. Okay, so that should be 48. 24 minus 48, which of course is minus 24. So A is minus 24. All right. Still have another question here. The question goes this way. The sum of the first nth term of the arithmetic progression 5, 11, 17, 23, 29, 35 is. So we don't know the type of progression this is. Okay, so we'll need to find out whether it is AP or GP. Let's find out. So I have the first term is 11. So for me to get, first term is 5, please pardon me. For me to have the second term, okay, so I have to add 6. 6 is added to 5 to have 11. All right, from 11, for me to have the next term, which is 17, 6 is also added. So this particular, all right, this particular sequence is actually AP, right? Not GP. This is AP. Okay, so we are looking for the sum of the nth term. The formula for the sum of the nth term of an AP is given as n all over 2, all right, bracket open, 2a plus n minus 1 multiplied by d, bracket close. All right, so all we just need to do is to put the values that we are being given. All right, so n still remain n because that's what we're looking for. We're looking for the nth term, n all over 2, then bracket open, 2 times a, the first term, a is the first term here is 5. So that's going to be 2 times 5. Then plus, I still have n minus 1. The common difference, d, is, the common difference, d is 6, all right? Okay. So Sn is going to be equal to n all over 2. Let's open this bracket. This is 10. 2 times 5 is 10. All right? This is 6n minus 6. So 10 minus 6. Or better still, let me write it down. This is 10. This is 6n. This is minus 6. So 10 minus 6 is 4. So xn is going to be equal to n all over 2. Bracket open, 4 plus 6n. Okay, so let's expand. So xn is going to be equal to 4n multiplied by 4, that's going to be 4n all over 2. 4n all over 2, then plus 6n square, still all over 2. 4n all over 2 will give us 2n. 6n square all over 2 will give us plus 3n square. So 2n plus 3n square is the xn. Okay. Then finally, this question goes this way. Find to infinity the sum of the sequence. Okay, you know very well that the sum to infinity is basically for GP, okay? We'll only find the sum to infinity of a geometric progression. The sum to infinity of a geometric progression. And the formula, right? Sum to infinity is equal to, is either you use a all over 1 minus r or r minus 1, depending on the value of r. So what is the common ratio? Let's look at what the common ratio is. You know, for you to be able to find the common ratio, okay, first of all, let's find the common ratio so that we know the formula to use. Okay, so the common ratio is always you divide the, okay, the first term or any term, okay, please pardon me, you divide the second term, that is 9 all over 10, all right, of course, by the first term. Or you divide the third term by the second term, it will give you the same thing because it's common. Or you divide the fourth term by the third term, all right? So 9 all over 10 divided by 1 is still going to give me 9 all over 10. So as you can see, all right, from what you have here, and I can see that r is actually less than 1 because r is a fraction, is 9 all over 10. So that means the sum to infinity I'm going to use is a all over 1 minus r. So this is going to be equal to a is the first term, which let's put that down. The 1 minus r. R is 9 all over 10. So the sum to infinity, you know how we are going to, what we are going to do, we'll simplify the denominator of the fraction. You know very well that the LCM of the fraction in the denominator is 10, okay? This is all over 1. Of course, 10 divided by 1, that's 10. 10 times 1 is 10, minus 10 divided by 10, that is 1. Or better still, you just cross multiply, all right? 10 times 1 is 10. Then, of course, 1 times 9 is 9. Then you divide it by 10 times 1, which is 10. All right, so this is going to be equal to 1 all over 10. 10 minus 9 is 1, then divided by 10. Okay, so you know very well that this is a reciprocal. So the sum of infinity, if you evaluate this reciprocal of 1 all over 10, it will reverse, okay? So that will give us 10. So the sum to infinity is 10. All right, so that is it. We are going to look at more in the next video, okay? So see you in the next video. Thank you very much.